I want to go home.
Hey, no, we need you, buddy.
No, you don't. I'm awful.
Come on now.
This one's coming right to you, Clark.
It's up, Clark! Clark! Clark, look out! All right, throw. Use your mid-stuff, not your head.
So, as you just saw in that video clip, we are going to be analyzing the hit that came from the bat and the ball hit Clark right on the head. And so the first step in analyzing that is using the x kinematics equation. So it's x equals 1/2 times a times t squared plus v naught x times t plus x naught. And so a, the acceleration, is equal to 0 in the x direction. The t, so time, is equal to 4.45 seconds, which we found by timing it in the video. X, the distance, is equal to 225 meters, which we found by looking up the average distance from a home plate to the edge of the outfield. And then we subtracted a little bit because Clark's not quite at the wall. And then x naught, so the starting position, is equal to 0 meters. So we did 225 meters equals 1/2 times 0 times 4.45 seconds to the second plus v naught x times 4.45 seconds plus 0. And so that brings us down to the 225 meters is equal to 4.45 seconds times v naught x. And then you get v naught x to be 50.56 meters per second, and so that's for the x direction. Okay, so the second part of the analysis is to do the y direction. So v naught y equals a times t plus v naught y. And so v naught y, so the velocity, is equal to 0 because we split it in half because of the path in which the ball travels. So it starts here, it goes up in a parabola shape, and then it lands on Clark's head. So we split it in half, so right here and right here, the velocity in the y direction is equal to 0. Okay, so then the velocity originally is what we're looking for, and the acceleration is just gravity, so negative 9.8, and then the time is still 4.45 seconds, but since we split it in half, it's divided by 2. So 0 equals negative 9.8 times 4.45 over 2 plus v naught y, and then it becomes negative v naught y equals negative 21.854, and then v naught y equals 21.854 meters per second. So that's the velocity in the y.
Hey, Mikaela, what's for dinner?
Oh, Mom says we're mac and cheese. Macaroni and cheese, and that makes garlic bread. Yes. Oh, are you ready for the video?
Yeah, of course.
Okay, 1 second. Let me get my lightsaber on. Okay, so the third step is to find the angle in which the ball came off the bat. And to do this, you just use the velocities that we just found. So v naught y, which is equal to 21.854, and v naught x, which is equal to 50.08. If you plug those into the equation, tan theta equals v naught y over v naught x. And so tan theta equals 21.854 over 50.08. And when you plug that in, you do the inverse of tangent times this fraction, and then you get theta to be 22.41 degrees.
Okay, so here you will see that if you change the angle by 1.5 degrees, how it affects the whole equation. So we got the v naught value through the kinematics equations that Mikaela did before, and then we followed this equation, v naught sine theta equals v naught in the y direction. And so we took our 55.08, which is a v naught, and times it by sine 24 degrees, because that's 1.5 more than sine 22.4, I think. And that gives us the v naught value in the y direction, which is 22.40 meters per second. And then we did the same thing. Instead, this time we found the v naught, the velocity, in the x direction. And so in order to do that, we had to times the V naught by cosine of 24 degrees. And then we got the velocity in the x direction, which was 50.31 meters per second. And this shows how everything would be affected if you just change the theta value.
As we saw from before, when Nida changed the angle from 22.4 up to 24 degrees, the V naught x changed from 50.56 to 50.31, and the V naught y changed from 21.854 to 22.4. So, ignoring the y values and just first plugging in the new x values that we have, plugging that back into the equation to see how far the ball will travel in the outfield. If you plug in 0 for the acceleration and the time squared of 4.45, since that's how long it took to get to the outfield, and then add the new V naught x of 50.31 times the time, which is 4.45, plus 0 of the original x position, you get 223.88 meters, which the original meters which caused Clark to get hit on the head was 225, but since that is nearly 1.2 meters short, that would not hit Clark on the head. So just a small adjust of the angle from the degrees that the batter hit, that would cause Clark not to get hit in the head by the
So
ball.
we also use the impulse momentum theorem to find force, because that's also going to impact where the ball lands. Okay, restart. I'm sorry.
Just go, it'll cut it out.
Okay. You're distracting me.
I'm
Okay.
literally sitting here. Do you want me
So
to say the first line?
no, I can do it. So we also use the impulse momentum theorem to find force, because that's also going to have a big impact on where the ball is going to land and if it's going to hit him in the head. So the impulse equation is force times time equals the mass of the baseball times delta V, which is just the change in velocity. So we already talked about how t equals 4.45 seconds, and we googled the mass of the baseball, and it's 0.143 kilograms. And the change in velocity is just 0 plus 55.08, so it just turns out to be 55.08. And we're trying to find force, so we plug that all into the equation, and we get, for F, we end up getting 1.77 newtons. Okay, so in conclusion, the ball hitting Clark in the head, like in the movie, is possible if you get all the values that we already talked about. But obviously it's really unlikely, because they all have to be exact, and there's so many variables that, if one's off, like we showed it with the angle, the whole entire thing just doesn't happen. So some of the variables that could change, I already said angle. Also the wind speed or air resistance could change where the ball would go. Clark's movement, if he moved even one step, the ball would land in a different place than he would. And another factor would be height, either height of Clark or the height of the batter, because that's just where the ball is making contact. And also I already talked about how the force and impulse can affect where it lands. So yeah, it's possible but very unlikely because of all the variables.
I smell cinnamon rolls.